All right, so here we go. Now, some of you are making this stuff a lot harder than it needs to be. Whenever you are finding the measure of an angle, find each angle measure. Whenever you're finding the angle measure, that's when you're not just going to use the regular button on your calculator. You're going to use that -1 thing. So these ones, all you needed to plug into your calculator was the inverse of whatever was given. This one was given tangent. And then 0.9325. And that gives me, if I hit second tangent, 0.9325. It does say round to the nearest degree. What does that mean?
Round
to the nearest nice number. So 42.99 would round to 43. So we're going to say that that would be 43 degrees. So what we've just figured out is a 43-degree angle is the angle that has that as its tangent value. So what would I do for number 2? I would hit second cosine so that I have this cosine -1 thing of 0.7547, and I get 41 degrees, right? This one I would hit second sine. That gives me the inverse sine of 0.8746, and that gets me 60.99, so I'm going to say that's 61 degrees. And then finally this guy, again the inverse tangent of 0.6249, and that gets me 32.00, which would be 32 degrees. Questions about those four? Okay. A lot of people got stuck on the next ones also. Find the value of all 3 trig functions, which means I want, of angle z, sorry, which means I want sine z, I want cosine z, and I want tangent z for all of these triangles. So if we remember our famous, and by the way, when you get your test, if I was taking the test, that's the first thing I would write at the top of the test so that I could refer back to it the whole time. So here is z. That's this angle. So what's opposite? 7 over hypotenuse, 25. Can that reduce? So that's my answer for sine. A lot of you were trying to make it a lot more difficult than it needed to be. It's really that simple. Remember, your hypotenuse is always directly across from your, sorry, let me turn my phone off. Your hypotenuse is always directly across from your right angle. And then if you look at the angle itself, it's made up of 2 sides, this side and this side. One side is the hypotenuse, the other side would be your adjacent side. The side that is not involved in making up that angle at all is your opposite. So cosine, that's my adjacent over hypotenuse. So what's adjacent z? 24. What's my hypotenuse? Still 25. Can that reduce? Nope. That's my cosine. By the way, it says leave as a fraction, no decimals. So if you put a decimal, it will be marked wrong on the test. And tangent is opposite over adjacent. So opposite is 7. Adjacent is 24. That can't be reduced, so those are my 3 trig ratios. Easy peasy? Okay. Over here, again, sine z, cosine z, tangent z. Here's z. What side is opposite? Opposite. What side is adjacent? And my hypotenuse is right there. Whoops, if I can spell. All right, so sine is opposite over hypotenuse. That would be 12 over 37. Can that reduce? No. Nope. If I wanted to check to see if it could reduce, I come here and I do 12 fraction button 37. And if I hit enter, it doesn't reduce. That's the lowest or the most reduced form. Cosine z would be adjacent over hypotenuse. That would be 35 over 37 also cannot be reduced. And tangent would be opposite over adjacent. Can that be reduced? I don't think so, but let's check. 12 over 35. Nope, can't be reduced. By the way, we talked about this before, but since all three of these numbers are nice numbers, 7, 24, and 25, what do we call that? A Pythagorean triple. Remember that? This is also a Pythagorean triple. This is also a Pythagorean triple. And this is also a Pythagorean triple. What would make it not a Pythagorean triple? If it had a decimal or a radical or a fraction or something that made it not nice anymore. Okay? I'm recording, FYI.
You're what?
Recording. Okay, so let's see. Again, here's z. So sine z is opposite over hypotenuse. What's opposite? 27 over 45. I think that one can reduce. 27 over 45. Yep, reduces to 3/5. Again, if you don't know how to do fractions on your calculator, please ask me. There's no reason to still be afraid of fractions because your calculator can take away all of the fear. It can do everything for you. Okay, cosine would be adjacent over hypotenuse. Let's see if that can reduce. 36 over 45, 4/5. And then finally, tangent of z would be opposite over adjacent, 27 over 36, 3/4. Hooray. And the last one, z is now down here. Do you notice that? So sine z would be, what's opposite now? 36 over 39. 36 over 39 is 12 over 13. Cosine would be adjacent over hypotenuse, 15 over 39. Which is 5 over 13. And tangent would be opposite over adjacent, 36 over 15. Now this one, because it's improper, your calculator is going to give it to you as a mixed number, 2 and 2/5. If I hit second and then that fraction button again and then enter, it changes it back to an improper fraction. So again, please leave it as an improper fraction, not a mixed number. Now, when you are on your test, you don't need to give me this. This is what your final answer is. Make sense? So you may write that down just because you're showing your work, but this is actually the final answer that I'll give a grade for. Okay? Questions about those four? All right. Find the measure of the indicated angle or side. So this one we're looking for an angle. I'll call that angle x. And what do they give me with regards to x as far as opposite, adjacent, and hypotenuse? They give me adjacent and opposite. What uses adjacent and opposite? Tangent. So I'm going to say tangent of x equals opposite over adjacent. Now for this particular type of problem, when I'm looking for the angle, it doesn't matter if I reduce that or not because my calculator will already take care of that. Now what I have right here is actually just like the first problems. I have what the tangent equals. So what am I going to do? I'm going to do the inverse tangent of 18 over 30, and that's going to give me the angle degree measure. So let's see what the instructions say. Round angle measurements to the nearest degree. So I need the nearest nice number. So I'm going to hit my second tangent. 18 divided by 30. 30.96. What would I call that? How many degrees? 31 degrees. Because 30.9 would round up to 31. Okay. All right, over here, here's my angle x. What do they give me as far as opposite, adjacent, hypotenuse? 26 would be considered opposite, and 45 would be considered. So what uses opposite and hypotenuse? Sine. So I'm going to say sine of x equals opposite over hypotenuse. Again, when I'm trying to find the angle measure, that's when I use the inverse sine. So inverse sine of 26 over 45. By the way, I'm using the division sign, not the fraction sign. I think your calculator doesn't like you using the fraction sign on these guys. 35.2. Now, some people will get confused. They'll start looking at the 9. But if I'm rounding off to the nearest degree, I'm only concerned with 35.2. Does that keep it 35 degrees, or does that make it 36 degrees? That makes it 35 degrees. Okay, questions there? All right, now we're on to side lengths. So here's my missing side. Here's my angle, and let's talk about these sides. Would 19 be considered opposite, adjacent, or hypotenuse? Hypotenuse. Would x be considered adjacent or opposite? So what function, sine, cosine, or tangent, uses adjacent and hypotenuse? So I'm going to say cosine of 45 degrees is equal to adjacent over hypotenuse. How would I get x by itself? Multiply by 19. So x equals, now I just got to go to my calculator, 19 cosine 45. I do not use the shift cosine this time. I do not use that -1 thing. Why not? I'm not looking for an angle. So I'm going to hit enter. And this one, by the way, it says round side lengths to the nearest tenth. So this one, I'm looking at the 4, and because of the 3 next to it, is that 4 going to stay a 4, or is it going to become a 5? Stay a 4. So I'm going to call this 13.4 is what my x value is. Got it? Okay. Last one right here, 54 degrees. Would 17 be considered opposite, adjacent, or hypotenuse? Hypotenuse. Would x be considered opposite or adjacent? What uses adjacent and hypotenuse? Cosine. So cosine 54 is equal to adjacent over hypotenuse. How would I get x by itself? Multiply by 17. And again, 17 cosine 54. 9.99. Okay, let's look at this. This 9, the middle 9 right there, I need to look at this 9 to see where it is going to round to. Is this 9 going to round up to 10, or is it going to stay at 9? Up to 10. If it rounds up to 10, that means that this guy is actually rounding off to 10.0. So I would say 10.0. And people will ask, do I need the 0.0? Well, technically no, because 10 and 10.0 are the same thing. However, if it says round to the nearest tenth, by having that 0.0 there, it shows me that you looked at those 9s to make sure that it was rounded off appropriately. Okay?
So would it be wrong if you did put the point was?
It would look like you weren't following directions.
So, yeah.
So you should, yes. If it says round to the nearest tenth, you always want to give a digit past the decimal, even if that digit is a 0. Okay? All right, 13, 14, 15, 16. Solve the right triangles. What does it mean to solve the triangle? Find everything. All 3 angles, all 3 sides. Now, some of it should be given to you. So let's see. Here's triangle ABC. So I'm going to find angle A, angle B, angle C, and I'm going to find little a, little b, and little c. And again, how are those labeled? Little a would be the side that is opposite angle A. Little b is the side opposite big B, and little c is the side opposite big C, which should be your hypotenuse when you have an ABC triangle. So, what do I know? I know angle C is what? 90 degrees. What would this one be considered? This is a side, so it's either A, B, or C. What would you call it? It's across B, so we would call it little b. Right? And then 20 is across what? Is opposite A, so we would call that little a. So I need to find 2 more angle measures and a side. Let's start off with an angle measure. Let's say I want to find angle A. If I wanted to use the 2 measurements that are given to me, how are these 2 related to A as far as opposite, adjacent, or hypotenuse? Opposite, and so I would say tangent of A is equal to opposite over adjacent. How do I solve something that looks like that? Way back at the beginning, I do inverse tangent of 20 over 28. So second tangent 20 over 28. Again, round angles to the nearest degree and sides or segment lengths to the nearest tenth. So let's see, 35.5 would round to 36 degrees. So what did I just find? Angle A. Now I don't have much work left to find angle B, do I? I just take 180 minus 36 minus 90, and angle B has to be 54 degrees. Capiche? Now, last thing I need to do is find side C. Now, I could set up a trig ratio again, or I could do what? I could use sine or cosine, because both of those would use the hypotenuse, or I could use the Pythagorean theorem, right? 20 squared plus 28 squared equals c squared. So let's see, 20 squared plus 28 squared is 1184. Square root both sides. So I'm going to square root 1184. And that gives me, what am I rounding this off to? It's a side length, so I'm rounding it to the nearest tenth. That would be 34 point what?
How do you do the square root?
Hang on just a minute. Let me round this off first, and then I'll answer that. 34.40 would be 34.4. How do you do square root? You should be able to find it somewhere near your x squared button, or whatever your button is that you use to square. So mine happens to be right on top, so I have to hit second and then my squared button, and that's what pops up a square root on my screen. Okay? So, my triangle is officially solved because I have labeled everything. Now, half of it was given to me, but a good solved triangle shows me all 6 measurements all in one place. Okay? So, same thing for DEF. I need to find angle D, angle E, angle F. And what do I know as far as angles are concerned? I know angle E is my 90-degree angle. Yes? And I also need little d, little e, and little f. So let's see, what would we say 10 is? Little f, because it's directly opposite f. And what would we say 17 is? Little d, because it's directly opposite d. And so E is what we're looking for. So last time I found a angle first. Let's find E first. How would I find little e? Pythagorean theorem, right? E would be the hypotenuse because it's across from the right angle. So 17 squared plus 10 squared is equal to little e squared. 17 squared plus 10 squared is 389. So I square root those again. So I can hit second square root. And if I don't want to type in 189 again, or 389, I can find the button that says ANS. And I have to press second to get to it. Sometimes you don't. If you have a Casio, I don't think you do. And if I do that, it'll take the square root of the previous answer. So if the previous answer is a really long number, this is just a shortcut way to make sure that you get it in accurately. So what am I rounding this off to? 19.7 or 19.8? 19.7. Okay. All right, let's find angle D. There's angle D. And I don't want to use this 19.7 to find angle D, because if I made a mistake finding that, and I use it to find something else, I'm guaranteeing I'm making another mistake in the next one. So let's use what we were originally given, 17 and 10. How are 17 and 10 related to angle D?
Opposite.
Opposite and, oops. So what am I going to use? Tangent of D is equal to 17 over 10. So I'm going to use the inverse tangent. Whoops. How about inverse tangent, not inverse ta? 17 over 10. Second tangent of 17 over 10. And I get, we're rounding this one off to the nearest degree, so 59.5 would round off to 60 degrees. Okay. How do I find the third angle? 180 minus 90 minus 60, 30 degrees. Anything interesting about that by any means? It's a 30, 60, 90 triangle. However, since I had to round it off to 60 degrees, it's not exactly a 30, 60, 90 triangle, but it is about as close as you can get. Okay. All right, number 15. Let's see. We've got angle J, angle K, angle L, and little j, little k, and little l. Okay, what do I know? Angle K is 90 degrees. What else do I know? Angle L is 63 degrees. Well, can I quickly find out angle J? 180 minus 90 minus 63 is 27 degrees. Do I know little j, little k, or little l? Which one is 17? Little j. Now, there is an x here, but it does say solve the right triangle. So I have to find both the x and the, which in fact I'm not going to call it x. I'm going to call this little k and this little l. So far so good? So let's say I wanted to find k first. If I wanted to find k, let's use angle L because it's given to us. If I use k, that's the hypotenuse, right? And how would 17 be related to angle L? Adjacent. What uses adjacent and hypotenuse? Cosine. So I'm going to say cosine of 63 is equal to 17 over k. So I'm going to multiply both sides by k.
Why not by 17?
Why not by 17? Because we never multiply by the numerator.
Oh.
Right? Because that would just give me 17 times 17 on the top, and it doesn't do anything to get rid of the fraction. Okay, so I have k cosine 63 equals 17. How do I get k by itself? Divide by cosine 63. So k equals 17 divided by cosine 63. 37 point what? I can't see it. 37.4. Alright, now to find L, last one. I could use Pythagorean theorem if I wanted to, but if I use Pythagorean theorem, that involves using something that I already found, and if I made a mistake there, I don't want to make a mistake again. So I'm going to use angle L still, because it was given, to find little l, and I'm going to use the adjacent. Little l would be the opposite. So if I use opposite and adjacent this time, what am I going to use? Tangent. So I'm going to say tangent of 63, which is angle L, is equal to opposite over adjacent. How do I find L? Multiply by 17. And little l equals 17 tangent 63. 33.36. What does that round off to? 33.4. And there is my triangle solved with all 6 pieces of information. Okay. Why are these ones the most time consuming? Because it's like 3 problems in one. You have to find 3 pieces of information, whereas before you were just finding 1 piece of information. Okay. Oh, is that mine?
Yeah.
Thank you. Woohoo. Okay. Last one here for the solving. Angle P, angle Q, and angle R. Little p, little q, and little r. What do I know? I know angle Q is 90 degrees. What other angle do I know? P is 37 degrees. Let's find that third angle really quick by doing 180 minus 90 minus 37, 53 degrees. All right. Let's see. Again, here's that X. I'm actually going to call it little p because it's right across from big P. Boom. And little q, those are the 2 sides we need to find. And I happen to know little r, that is 17. So let's find P first because I can do 37 degrees and I can do opposite and adjacent, which is tangent is equal to P over 17. How do I get P? Multiply by 17. So 17 tangent 37, 12.81, which I would call that 12.8. Now, I don't want to use P or little p to find little q. So instead of using little p, I'm going to use these 2, which is adjacent and hypotenuse. So I'm going to use cosine now. So let's see. Cosine 37 is equal to adjacent over hypotenuse. What do I do? Multiply by q. That gives me q times the cosine of 37 equals 17. And I'm going to divide both sides by cosine 37 to get q. So 17 divided by cosine 37, 21.28. What does that round off to? 21.3. Because I used the adjacent side and the hypotenuse. That's the K part of SOHCAHTOA. Okay? So there's all of them again. Any questions about those 4? Now's your chance to ask. Tomorrow I can't answer any of this. If you come up and ask me, is this side the adjacent, is this side the opposite, I can't answer that tomorrow. You've got to be able to figure those out. All right, backside. Find the missing side lengths. Now what's fancy about these 6 is they are all our special right triangles. What do we know about special right triangles? Well, if we have a 45, 45, 90 triangle, then guess what? We have x to x to x radical 2. What does that mean? That means the sides are the same and the hypotenuse is equal to a side times radical 2. If we have a 30, 60, 90 right triangle, our ratio is x to x radical 3 to 2x. So when we have the short leg, that would be the leg opposite the 30-degree angle. The long leg, you take the short leg and you multiply it by radical 3. The hypotenuse, you take the short leg and you multiply it by 2. Okay, so these are in the same order. X would be across from a 45-degree angle. X would be across from a 45-degree angle. X radical 2 would be across from a 90-degree angle. And over here, x would be across from 30, x rad 3 would be across from 60, and 2x would be across from 90. So looking at number 17, what do I have? 45, 45, 90, or 30, 60, 90? 45, 45, 90, which means that if I need to find u and I need to find v, which one is going to be the same as that guy? V, the other leg. So that's 13 radical 2 over 2. So there's my x side and my other x side. How do I get the hypotenuse? I take 13 radical 2 over 2, which is a side or a leg, and I multiply it by radical 2, because that's what this says. It says take a leg, multiply it by radical 2. Now I'm going to call that radical 2 over 1. That means the same thing. That gives me 13 radical 4 over 2. What is radical 4 though? Square root of 4 is just 2. So that gives me 13 times 2 over 2, which is 26 over 2, or just 13. So side U is just 13. There's my missing side lengths. Notice it says leave your answers as radicals in simplest form. That means you can leave radicals or reduced fractions, but you can't give me decimals. Okay? Are there any other 45, 45, 90 triangles while we're at it? Number 20 is also a 45, 45, 90. So they give me a leg, so what do I know about y? Y is also 5 radical 3, right? Because the legs match. And then how do I find x? I take the side length, the 5 radical 3, and multiply it by what? Radical 2. That gives me 5 radical 6. Can I draw a tree for 6? I can, but nothing comes out, right? So the hypotenuse is just 5 radical 6. Any other 45, 45, 90? 21. I need x again, and I need y. They tell me one of the legs, so what's the other leg? The other leg is y, so what's it going to be? 9 radical 2. How do I get the hypotenuse? 9 radical 2 times radical 2. That gives me 9 radical 4. What is radical 4? 2. And 9 times 2 is 18. So there's my two sides for those guys. Questions about the 45, 45, 90s? Okay. Let's see. Number 18, 19, and 22 are all 30, 60, 90 triangles. So which one looks the easiest? Let's see. If they give me the short leg or the hypotenuse, that's the easiest. And I think the only one they do that is 19. So 19, they give me the hypotenuse. If the hypotenuse is 2x, how would I solve for x? Wouldn't I divide by 2? So let's see. I need to find x and I need to find y. Now this is a little confusing because I'm using x, but I'm not actually finding x. Because x, they're calling the long leg. I'm actually finding y. Do you get that? So I'm actually going to call it y, just so I don't confuse myself. What's 84 divided by 2? 42. So y is 42. Couple different options. I can use Pythagorean theorem at this point. Or, once I know that this is 42, how do I get this side?
42.
I multiply by radical 3, so that's 42 radical 3. Way quicker than using the Pythagorean theorem. Okay. All right. Let's see. This time they give me the long leg. So they give me radical 15, which is this guy right here. Sorry, you can't see that. It's my x radical 3. So if radical 15 equals, now I'm not going to call it x radical 3, I'm going to call it y radical 3 again because they're naming their triangle a little differently, equals y radical 3, how would I get y by itself? Divide by radical 3. Now our rule with dividing is we can divide numbers that are both inside a radical, or we can divide numbers that are both outside a radical. So I can divide 15 divided by 3, but my answer has to stay inside the radical because both 15 and 3 were in the radical. So I get radical 5, right? So y is radical 5. How do I find x then? So if I just found the short leg, I have to multiply it by 2 to get the hypotenuse. So what's radical 5 times 2? 2 radical 5. And finally, one that doesn't use x and y. Let's see. I have the long leg again. So b is the short leg. So instead of x in my ratio, I'm going to use b. So this right here, 12 radical 2, if that's the long leg, that's equal to b radical 3. So how do I find b? Divide by radical 3. Now this one's a little bit more complex because 12 radical 2 over radical 3. I can't divide the 12 by the 3 because one's inside the radical and one's outside. But I got to get that radical off the bottom, so I need to multiply by radical 3 over radical 3. What does that give me? 12 radical 2 times radical 3 gives me 12 radical 6 over, what's radical 3 times radical 3? That's radical 9, isn't it? And what is radical 9? It's 3. And now I have some reducing I can do. That becomes a 4 and that becomes a 1 because those were both outside. So what do I finally get for B? 4 radical 6? Whew. All right. And my hypotenuse A then would be twice that. So what do I get when I multiply that by 2? 8 radical 6. Questions? Okay. Word problems. Yes.
For like our answers, you know, for example, 22.
Uh-huh.
You know how we said that 12 radical 2 over 3 over radical 3 equals B? Can we just punch that into our calculator and then put the answer and then go from there? Or we have to show
Depends on if your calculator will simplify the radical or if it will put it as a decimal. If it goes to a decimal, then no, because it says no decimals in the answer. Okay? Remember, this is code for no decimals.
We're just showing our work. We can go from that step to the answers.
Yep. All right. The hardest part of the word problems is what? Drawing a picture. A nursery plants a tree and attaches a guy wire for support. So we have a tree. We'll call this my tree. And attaches a wire for support. An 8-foot wire is attached to the tree and to a stake in the ground. So here's a little stake in the ground. We have the wire attached like that. So this is the wire. So this is what's 8 feet. From the stake in the ground, the angle of elevation always goes from the ground up, or from something up, is 42 degrees. And they're asking me to find the height of the connection point on the tree. Now that's not necessarily the height of the tree because it's suggesting that the wire might not be attached to the top of the tree. It's attached somewhere inside the tree. But I'm going to call this X because if you erased my tree from right there, I have a nice right triangle right there. So 42 degrees, I have opposite, I have hypotenuse, that makes sine. So sine of 42 is equal to opposite over hypotenuse. I'm going to multiply by 8. And that gives me 8 sine 42, 5.35. What do they say? Round to the nearest tenth. So 5.35 would round off to 5.4. It also says write a sentence. So I'm going to say the guy wire attaches 5.4 feet up, I'm running out of room, up the trunk of the tree. Capiche? All right. 24, the angle of depression from the top of a building. So I have a top of a building right here. Let's say that here's my building, there's the door, and then maybe we've got some windows, and it goes this way. I'm just looking at the top. So from the top of a building to a specific point on the ground. So here's the point on the ground. This would be your angle of depression. Not this, but this would be your angle of depression. And that's 32 degrees. How far is the point on the ground from the top of the building? So we're looking for this distance right here. Point on the ground, top of the building. I want to know the distance between those two things. If the building is 252 meters high. Well, my right triangle is right here, correct? Is 32 degrees the angle I'm going to use? No, because it's not in my triangle, is it? But I do know that this would be a right angle right here because we always go from straight there. So if this is 90 degrees together, can I find out what this one is? 90 minus 32 means that 58 degrees is what this is. So 58 is what I'm using in my triangle. So if I have adjacent and hypotenuse, I'm going to use cosine of 58 is equal to adjacent over hypotenuse, multiply by x. So x times cosine 58 equals 252. Divide by cosine 58. And x equals 252 divided by cosine 58. 475.54 would round off to 0.5 what? What are we talking about? Meters? So I would say the point on the ground is 475.5 meters from the top of the building. Questions about that one? That one's a little trickier because you've got your angle of elevation, then you actually have to know that these two angles will add up to 90 degrees. So to find the angle that's actually a part of your triangle, you have to subtract 32 from 90. Okay? All right, 25. Find the shadow cast by a 10-foot lamppost. So we'll call that my lamppost. If it's 10 feet tall, I'm going to label it 10 feet. The shadow. Now, a lot of people wonder, is this the shadow? No. You don't look in the air for a shadow. Isn't a shadow something that's only on the ground? So my shadow is right here. That's what I'm looking for. There's my right angle. 10-foot lamppost when the angle of elevation of the sun is 58 degrees. That's kind of tricky, but we're going to call that 58 degrees. Angle of elevation of the sun, that's kind of a confusing statement. So I'm going to use this one, so I'm going to say tangent of 58. And why am I using tangent? Because I know opposite and adjacent. I'm going to multiply by 10. That gives me, I'm sorry, multiply by x, not by 10. So x times tangent 58 equals 10. Divide by tangent 58. And x equals 10 divided by tangent 58. 6.24, so I'm going to call 6.2 feet. So what would my sentence be? The shadow is 6.2 feet long. Questions? All right, last two. I know I'm going fast on this, but since it'll be a video, you can go through and pause where you need to pause. You can fast forward where you need to fast forward, etc. All right, a man stands at the top of a 105-foot lighthouse and sees a boat. So how high up in the air is the man? He's 105 feet up. He sees a boat, so we'll say the boat is over here. The angle of depression. Now remember, the angle of depression, if he's looking down at the boat, the angle of depression is 37 degrees right there. Find the distance between the base of the lighthouse and the boat. Well, we'll pretend that I actually made that line up well. Here's my right angle. I'm trying to find this to find how far the boat is, but I don't have an angle in the triangle. So what do I do up here? I know that these two together have to equal 90. So I'm going to take 90 degrees and I'm going to subtract 37, which means this one is 53 degrees. So far, so good? Now, I have opposite and I have adjacent with regards to 53. So I'm going to use tangent of 53 equals opposite over adjacent. I'm going to multiply by 105. And I get x equals 105 tangent 53, 139.3. So let's write our sentence. The boat, good thing I don't teach English because I forget to capitalize letters sometimes. The boat is how far? 139.3 what? Feet from the base of the lighthouse. Okay. All right, last one. A trolley track car, or a trolley car track, rises vertically 40 feet over a horizontal distance of 630 feet. That's really confusing. But basically what it means is we have like a railroad track that's going up a hill. And it's saying that if it's rising vertically, so here's the track and the little car is going up. It rises vertically, which means from the start to the finish it has gone up 40 feet. But it takes 630 feet to do that. So that's my labeling. So over the course of 630 horizontal feet, it goes vertically 40 feet. What is the angle of elevation of the track? So that's what I'm looking for. So I would say tangent of x is equal to 40 over 630. This is where I'm going to use the inverse tangent. Again, I use inverse tangent when I'm looking for the angle measure. So second tangent 40 divided by 630. So I have 3.63. Let's go ahead and round that off to the nearest nice number. Actually, sorry, it says rounded to tenths. So 3.63 would be 3.6. So we're going to say 3.6 degrees. So I'm going to use the words they give me. Again, with the not capitalizing, the angle of elevation of the track is 3.6 degrees. Any questions? All right, let me stop the